that the solutions are extraneous or an empty set, because the argument is allowed to be negative. Okay, so let's solve this one. So there is no the bases are not equal. So the first thing I want to do is I select. I can rewrite this as 1.11 all to power x is equal to 7 divided by 0.07. So I have rewritten the function. All right, so now I want to, the next thing I have to do is take log of both sides, because there is no other way to simplify it. So yesterday, the other day, 2 days ago, we found that there are some of them, exponential functions, we can find the base to be equal. But this one, the bases are not equal. So what do? How do we solve it? Because we know that exponential functions and logarithmic functions are inverses of each other, we will take the logarithm of both sides. So with the log of 1.11 to power x is equal to log of 7 divided by 0.07. And then, according to the laws of logarithm, exponents can be written as coefficients. So x log of whatever is in the parentheses here is equal to the right-hand side. All right, so I can now solve for x. So I get the value of x. And then I divide the right-hand side with log of 1.11. So log of 7 divided by 0.07 all over log 1.11. So I get my calculator and put it in, then I'm finished up. So you have to do some manipulations before you put it in your calculator. All right, so the numerator says log of 7 divided by 0.07. So let me get that in. Log 7 divided by 0.07. And I can close that parenthesis. I can decide to hit enter and get the answer. Then I'll divide the answer by the denominator, which is log of 1.11, 1.11. When I close parenthesis, when I hit enter, I have 44.13. This answer is not negative, so the answer is correct. It's not extraneous. So my answer is 4.41. Okay, if you're just coming in, what we're doing is section 6.5 homework. So today we are doing 6.5 and 6.6. And on Saturday, the unit 3 test will open. On Sunday, unit 3 test will open. Both quiz, unit 3 test and quiz will open and will be due on Monday. Okay, so let's do number 6. And after this, I think I have to let you finish the homework. This is homework for tonight. So I'm just doing some of them so that I want to make sure you know you should be able to do it. So before I start solving I can start solving the problem by taking all the constants to the right-hand side. So I have 2 into 1.08x per x is equal to, I want to move 1 to the right-hand side. So 6 minus 1 is 5. I can just write 5 so that makes my world easier. Then divide both sides by 2. So I have 1.08 to power x is equal to 5 over 2. There is no way I can have equal bases on both sides. Exponential equation, there is no way I can have. So any time this happens, to know you can solve the problem. It is not, you cannot say I can't solve it, because exponential and logarithmic functions are inverses of each other. So take log of both sides. Take log of both sides. So I'm going to take log of 1.08 to power x equal to log of 5/2. And then exponents are coefficients. So I have x into log of 1.08, 0.08 is equal to, bring down what is here. Now that I have isolated, I brought x down, I can divide both sides by the number, the coefficient of x. So that is divide both sides by log of 1.08, divide both sides by log of 1.08. And so I can now finish up on the left-hand side. All right, so x is equal to the log of 5/2 divided by log of 1.08. I will get my calculator. And get the numbers. All right, I'm going to clear log of 5/2. So this is log here, common log. You see, the base is not written because it's a common logarithm. So log of 5 divided by 2, 5 divided by 2, close parenthesis. I like to get the answer 2. And then, so now I have divided by the denominator, which is the same as log 1.08, 1.08, close parenthesis. And when I hit enter, I have an answer 11.91. So that is my answer. The same thing goes so any questions so far? Any questions so far? Okay, we can continue. And I think that's all. They are all like this, but I can also do, let me check and see, because I don't want to do all of them. It's a homework for tonight, so you should be able to do it. Okay. Let's do some of those ones that have a lot of numbers in them. So let's start with one natural log. So let's get one that has natural log. Natural log. So this one has natural log, number 7. Natural log. So this equation is in logarithmic form, and I'm told to solve for x. So remember, logarithm and exponential function are inverses of each other. And I have already said that if it is natural log, you exponentiate. You use base e. So the first thing I want to do is divide both sides with the coefficient of natural log. So I now have natural log of x is equal to 5 when I divide both sides by 2. In other words, I just isolated natural log. I haven't finished solving it, okay, because I have to get the value of x, not the value of natural log. So e to power natural log of x is equal to e to power 5. Because it is natural log, I will exponentiate with e. Natural log goes with e. And we already know that e to power anything, e to power natural log of a number is equal to x. So x is equal to e to power 5. If I'm told to get the answer, I can just put that in my calculator. I can leave my answer like this. E is a number, 2.72. So to power 5, I can leave my answer in exact form like that. Okay, so let's go to the ones that are, okay, this is not base. Let's look at number 9. Number 9 is not even base 10. So let's look at that. So this is number 9. And number 9 is not base 10. So I can change it back to exponential function. So all the manipulations you have to do, remember you have to apply the laws of logarithm. So I can change this back to exponential function. So the arguments 6x minus 6 is equal to 6 to power 4. So remember last week we said that a number can be converted from exponential form to logarithmic form, or the reverse. I just did the reverse so that I can solve this problem. And so I have 6x. I will throw this negative to the right. It's equal to 6 to power 4 plus 6. And then I can solve x is equal to 6 to power 4 plus 6 divided by 6. Then I'll put it into my calculator. At this point, you can finish solving it though. At this point, you can finish solving it. So, but I know you have to put it in your calculator. It's no longer difficult to solve. I'm not going to put this because we need to get to applications today. We need to make sure we get to applications. The same way we did number 9, we'll do number 10. Okay. Right here, in number 11, we see a different kind of and we want to see how we can tackle this. Okay, how do we tackle that? First of all, I have a natural log on both sides. So I will take, I can exponentiate all of them this time. Let's see how it goes. E to power natural log of x plus e to power natural log of x squared is equal to e to power 2. Let's see how this goes. So this one is x plus this one is x squared. And this one remains e to power 2. And so we have a quadratic function, x squared plus x. Remember, we have already solved quadratic functions. I'll put this one to the left, e to power 2, which is now a constant. You can now solve this equation with quadratic formula. You can now solve it with a quadratic formula, and you can get the answers now. Easier to solve, and you get to values of x. The negative value is not a real solution. The negative value is not a real solution. Let's look at number 12. It's almost like we're doing all the homework in class. But anyway, we have to do that because we have a test. Okay, so first of all, let's tidy this up. There are so many other ways we can do this. In fact, the other one we could have tidied that up too. So let's tidy this one up. Because it is addition, we can actually make it log to base 8 of x multiply x minus 12, because addition is multiplication. We're applying the laws of logarithm. Okay, so we're applying the laws of logarithm, and then we have x into x minus 12 is equal to 8 to power 2. And we distribute x into the parentheses. So we have x squared minus 12x is equal to 8 squared, which is 64. And so this is a quadratic function, which we can now solve. Everybody can solve that by now. So we have x squared minus 12x minus 64 equal to 0. And then you can solve this by factorization. It can be, I hope you can solve by factorization. If not, use quadratic formula. And then make sure you test the values. Test the values. And by the way, let's go back to this question. Let's see. Let me go back to this question. I just want to make sure that there are two ways of solving this problem. So let's let's also solve it. Make sure we do the both ways. According to laws of logarithm, we know that I can say natural log of x, addition is multiplication, multiplied x squared. Let's see, both answers are going to be the same. So according to laws of logarithm, I can connect the left-hand side, and then I will have is equal to 2. So this is x to power 3 actually. So if I apply the laws of logarithm, I'm not sure I'm going to get the same answer, equal to 2. Okay, then I'll take e to power. I'll take the, I raise them to exponents of e. So let's see. So I see e to power, natural log of x to power 3 is equal to e to power 2. And so x to power 3 is equal to e to power 2. So maybe this one might actually be the best way. Find cube of both sides, cube both sides, and solve the question, solve the equation. Okay, the same laws of logarithm, we shall apply the laws of logarithm here. On the left-hand side, we can pull all of them under the same logarithm. There is addition here. So we combine them. The first argument is x plus 7. The second argument is x minus 7. And then I will be equal to 5. And then I can change the logarithmic equation to exponential equation. And by the way, this is the same as x squared minus 7 squared. 7 squared is 49 because it's difference of two squares. And then I have 2 to the power 5. So x squared minus 49 is equal to 2 times 2 times 2. That's 32. 32. If I add 49 on both sides, it's now easier to simplify. 49. This cancels. So I have 9 plus 1 is 1 here. And 4 plus 4 is 8. So I have 181 on the right-hand side. Oh, no. I'm sorry. That's not right. So let's do this again. So we have plus 49. Plus 49. So this is 1 and this is 81. Much better. So x squared is equal to 81. Therefore, x is equal to plus or minus 9. Well, all we need to know is that the negative argument, we have to be careful. We have to test the solutions. We get test the solutions. The one that gives us a negative argument is not a real solution. So one of the solutions can be extraneous. So you got to test it. Test 9 here. If I put 9 plus 7, I will have a positive number. 9 minus 7, I have positive number. Okay, well, let's try negative. Negative 9 plus 7, I have negative number. Negative 9 minus 7, I have negative number. So negative 9 is not a real solution. Only x equal to 9 is a real solution. So x is equal to 9 is the real solution. X equal to negative 9 is an extraneous solution. So we got to be careful after when we find the equation and solve them. Okay, we can let's bring all this together. This is base E, so we can just collect all the E. Natural log of E to power X minus 4 times natural log of E is equal to natural log of E to power 5. All right, so we can bring them together. We just write under one big natural log of E. And then, by the way, we can collect this to the left-hand side. It is natural log of E to power 5 and equal to 0. So let's collect all of them according to the laws of logarithm. So this is going to be x. And by the way, if I simplify this, natural log of E to C, this number is already, okay, let me write what I'm saying. Natural log of E to power X is already X. So this is already X here. 4 times natural log of E. Natural log of E is 1. Minus 4, we take 4 here. Natural log of E to power 5 is 5. So there's actually nothing to solve here. Plus 4 plus 5 plus 4. So X is equal to 9 here again. Because we know that natural log of E is 1. We also know that, so we can solve it. There are so many ways you can solve the problem. And everybody know, number 17, everybody, you know that square root can be, you can change, rewrite. I'm talking about rewriting number 17 before ever you start solving it. You have to rewrite it so that it's manageable. So the left-hand side, we have to rewrite. So log of x minus 4 all to power 1/2, because the square root is equal to log x minus 4. Okay, so the next thing I want to do, I can bring both sides, both of them on the same side. They are all base 10. So I can bring them on the left-hand side. So I'll bring this one, and it's going to be negative log x minus 4. And all is going to be equal to 0. Bring this down. Okay, well, let's see if our simplification will make sense. According to the laws of logarithm, this is 1/2 log x minus 4 minus log x minus 4. Now let's bring them under the same logarithm. So 1/2 is outside, and if I bring them, I'm going to be dividing, because subtraction is, in subtraction here is the same as division. So this is the same as log x minus 4 divided by x minus 4. And log of x minus 4 divided by x minus 4 is log 1. And log 1 is 0. So everything here is going to be 0. Log 1, let's check that out. What is log 1? Log 1, what is log 1? Anytime I start solving a problem and I get log 1, what in the world does it mean? Log 1, close parenthesis, hit enter. Log 1 is 0. So that makes our world easier. So everything goes back to 0. 0. Okay, I think we have done enough on 615. So let's go to applications. You can, even though this looks ugly, you can isolate them. You should be able to isolate them, solve for the missing variable. Okay, given the equation is quadratic, solve the equation and give the exact solution. Well, we can say, in this equation, let u be equal to e to the x. you can always do some manipulations. So here I can rewrite the equation e. Now, since I said that u should be e to the x, then that means u squared, I can rewrite the equation as u squared minus 10u plus 24 equal to 0. So this is the kind of manipulations. See, I want you to know that this unit is not just because of passing the test. Unit 3 is not just about passing the test. You carry unit 3 to calculus. You carry unit 3 to calculus. So you need to understand it. And make sure you can apply most of the things here. And then let's see if we can solve this by factorization. Otherwise, we use a quadratic formula. What are the factors of 24? 4 times 6 is 24. Okay, so we can say that 24 is equal to negative 4 times negative 6, and we can solve that problem. Important thing, I will let you finish it because we don't really have all the time. So the same thing with number 24 here. When you finish, you get the value of u, you go back and say, remember you said u is equal to e to the x. Now, with the first value, you substitute it and solve for x. All right. Okay, so anyway, let's finish it so that we can see how our back substitution. So we can see how our back substitution will be. So u squared, I told you I like to do it this way, minus 4u minus 6u plus 24 is equal to, I like to do it by grouping. Group. So the first group is right here, second group is right here. If everything is good, it means that what is in the parentheses are equal. So u into u minus 4 here. I'll take minus out, and I'll factor 6 out into u minus 4 equal to 0. Okay, yes, factorization is working. So u minus 6, u minus 4 are the factors. Since u minus 6 and u minus 4 are the factors, the solutions are 6 or 4. Can be or and. Okay, so now we're going to go back and solve the problem. So when u is 6, and remember that u is equal to e to the x, then I can solve for x. Solving for x is taking natural log of both sides, because see, there's no way the base can be. You see, this is a long problem. So there's no way that base e can be 6. So natural log, and remember that natural log and e go together. Natural log of e to power x. So, and then you solve. Remember that the laws of logarithm says the exponent is coefficient. Right here, natural log of e will go away because natural log of e is 1. And therefore, your answer is x equal to natural log of 6. So leave your answer in. So x is natural log of 6 is okay. You don't have to simplify that anymore. And then your next question, the next one says u can be 4 also, because we said that u is e to power. So when u is 4, then I have 4 is equal to e to power x. Okay, take natural log of both sides. Natural log of 4 is equal to natural log of e to power x. All right, then according to the law of logarithm, x multiply the right hand side, x multiply natural log of e, and natural log of e is 1. And so another answer, possible answer, is x equal to natural log of 4. believe me, you will be doing this when you get to calculus. Even if you don't, even if you get to have an easy test in Unit 3, you will need to know all this because you take it to your calculus class. You have to know logarithms and exponential functions very well to do your derivatives and integration. You need to know them very well. And your teacher will assume that you already know them. And by the way, it's time for us to go to uh, another section, 6.6. 6.6 is applications. So let's see.